In this proof of concept, Security Onion was installed in standalone mode, and the Elastic Agent was installed on the Windows virtual machine. Test data was ingested, and threat hunting was carried out in a safe, controlled environment. Installing Security Onion Manager. Create new virtual machine and select Oracle Linux 9. Enter the VM name and location. Select disk size to 300 GB. Set memory to 16 GB. Set processes to 4. Select the Security Onion image file. Add 2 network adapters, one connected to LAN and one connected to NAT. Click Finish and power on the VM. Select Install Security Onion. The VM will go through initialization process. When prompted for warning, type Yes, then create an admin account. Security Onion will continue with the installation. This process can take a while. When prompted, press Enter to reboot. Log in using the admin credentials. Select Yes, then Install. Select Standalone and type Agree. Select AirGap and give your system a host name. Skip the description. Choose the network adapter that connects to your LAN. Select and assign static IP address for your management interface. Enter your gateway IP address. Leave DNS servers as default. Enter a generic value for your DNS search domain. Select Yes for the default Docker IP range. Choose the second network adapter for packet monitoring. Create an admin account in email address format for the Security Onion console web interface. Enter a password for the admin account. Select IP to access the web interface. Select Yes. Enter your subnet to allow access. Review your settings and select Yes to proceed. Security Onion will now run an automated configuration script. This may take 10 to 30 minutes depending on your system. After installation is complete, verify that all containers are running by entering the following command. From the Windows VM, open a web browser and navigate to https://10.0.0.100. When prompted for a warning, click Advanced and select Accept the risk and continue. Log in to SOC Web Interface using the admin credentials. Navigate to Grid page and verify that all containers are running on the Security Onion Manager. Navigate to Administration, then Configuration. Select the quick link. Allow Elastic Agent endpoints to send logs. Add the agent subnet. Click the green checkmark to apply changes. Click on Options and synchronize Grid to push out changes. Please note that this can take several minutes to complete. After waiting for several minutes, verify connection to 10.0.0.100 on port 8220 by running the following command in PowerShell from your Windows VM. You should see true for TCP test succeeded. Navigate to the Downloads page and download the Windows Elastic Agent. Right-click on the Elastic Agent and click Run as Administrator. Click More Info, then select Run Anyway. Installation will be initiated. After installation is complete, check the Elastic Agent installer log. You should see Elastic Agent has been successfully installed and Elastic Agent installation completed. To verify that host logs are being ingested, navigate to the Dashboards page and select Host Overview on SOC Web Interface. This gives us high-level view of host logs that are being ingested via Elastic Agent. We see sysmon logs and Windows event logs being ingested from our Windows VM. Introduction to Security Onion. On the Overview page, you will find a silhouette icon in the top right corner of the web interface. Clicking this opens up options like the cheat sheet. The cheat sheet is a handy reference that lists commonly used commands for day-to-day tasks in Security Onion. The grid displays all the nodes that have been deployed in your Security Onion setup. In this example, there is only one node listed. At the bottom of the node status panel, click the test data icon. When prompted, click Yes to proceed. This will load sample test data into Security Onion. Please note that this can take several minutes to complete. Go to the Alerts tab in the web interface. This is where you will find alerts for suspicious or potentially malicious activities in your environment. Click on the number next to the rule name. To escalate the alert, click the triangle icon and select Escalate to New Case. You can also fine-tune how a rule behaves by clicking on the rule name and selecting Tune Detection from the menu. This opens the Tune Detection page, where you can enable or disable the rule, or adjust its settings to better suit your environment. Go to the Cases tab. You will see any cases that have been created, usually named after the alert that was escalated. As you investigate, you can record notes and observations to track what triggered the alert. Click on the binoculars icon to open the case and add your comments or findings. Head over to the Hunt tab. At the top of the Hunt page, you will find a query box, along with a list of pre-built queries you can use straight away. For example, the log type query shows all the different types of logs that Security Onion has collected. If you want to focus your hunt on sysmon logs, click on Windows and select Include to add it to your search query. You will now notice that the Group Metrics pane is filtered to show only records from the Windows dataset. To narrow it down even more, you can select Windows Sysmon Operational and click Include to filter specifically for Sysmon operational logs. The Group Metrics pane shows only data from the Windows Sysmon operational dataset. Scrolling down, you will see a list of individual Sysmon events that have been captured. You can click to expand any event to view detailed information about what was captured in that specific log entry. To refine the results even further and focus on File Create events, click on File Create and select Include to filter for those specific logs. Go to the Dashboards tab. Dashboards include a range of pre-built visualizations to help you quickly interpret and analyze incoming logs. For example, if you want to analyze HTTP traffic, select HTTP from the drop-down menu to load the relevant dashboard. This will load a HTTP dashboard that provides visual insights and metrics related to HTTP traffic observed in your environment. You can refine your view by filtering based on destination port. For instance, if you want to focus on non-standard HTTP traffic, you can exclude destination port 80 from the results. This will show HTTP traffic that is using non-standard ports, which could indicate a suspicious behavior. Security Onion also captures full network traffic using packet capture. To view a packet capture, scroll down to the event list, click on the first record, select Actions, then click on PCAP to open the capture for that specific network flow. This opens a web-based PCAP viewer. Here, you can inspect details like the source and destination IPs, port numbers, and TCP flags involved in the connection. To view the raw packet data, click on the list icon at the top of the PCAP interface. To hide the hex dump, click on the HEX icon. If you need to dig deeper, you can either download the PCAP using the Download button at the top right, or send it directly to CyberChef by clicking the CyberChef icon. As well as pivoting into PCAP from a specific alert or event, you can also pull custom PCAPs from your sensors based on your own search criteria. For more details, refer to the documentation. Go to the Administration tab. Under Users, you can create, disable, or edit user accounts for accessing the web interface. The Grid Members section lets you add or remove nodes to scale or manage your Security Onion deployment. The Configuration section allows you to manage settings, firewall rules, and log retention for your environment. The License Key section activates advanced enterprise features that are not available in the free version. Kibana is Elastic's web-based interface for exploring and visualizing data stored in Elasticsearch. Clicking on Kibana will open it in a new browser tab. To focus on specific data, for example, HTTP logs, click Network under the Event category, then choose HTTP under Datasets. You will see detailed tables and visualizations specifically related to HTTP data. Elastic Fleet is where you manage and configure your Elastic agents. Clicking on Elastic Fleet in the web interface opens it in a new tab. You will see a list of registered agents. These represent the hosts currently enrolled and reporting data to Security Onion. The OS Query Manager lets you send live OS queries to endpoints. Clicking on OS Query Manager opens it in a new tab. To get started, click New Live Query. For query type, select Single Query. For agents, select All Agents. For query, enter the following query and click Submit. Security Onion will then contact all selected agents and request user account information regardless of what operating system each endpoint is running. Open InfluxDB by clicking InfluxDB in the web interface. InfluxDB shows similar information to what you see on the grid page, but it also provides historical telemetry. This is especially useful for spotting trends, such as changes in CPU usage over time. CyberChef is a browser-based tool used for encoding, decoding, and analyzing data. For example, copy and paste the following string into the input box. Drag and drop from base 64 and decode text into the recipe panel. For decode text, select the UTF-16LE encoding. The decoded command appears to show the attacker adding themselves to the local administrators group. The Navigator is a visual tool built on the MITRE ATT&CK framework, showing which attacker techniques your environment is currently able to detect. It does this by mapping your enabled Sigma rules to specific techniques, with color coding used to indicate which areas are covered. As you enable more rules, the chart updates automatically. Updating Security Onion. To update Security Onion, go to the Overview tab, click the silhouette icon, and then select Blog. The blog shows direct link to the release notes. Refer to the documentation for more details on updating Security Onion. Alert Triage and Case Creation. To review alerts, go to the Alerts tab. At the top, there is an Options menu that lets you customize how alerts are displayed. To focus on high-severity alerts, click on High, then choose Include to filter your results. You can also sort the alerts by severity level by clicking on the Event Severity Level column heading. By default, alerts are grouped by rule name. If you want to see the individual alert events, click on the count number or the rule name, then choose Drill Down. For example, click on GPL NetBIOS SMB IPC Unicode Share Access and select Drill Down. This reveals 10 individual alerts triggered by 3 different source IPs connecting over SMB to 2 different destination IPs. If the traffic is known to be safe, you can make a note of it for future alert tuning, and then acknowledge the alerts by clicking the bell icon. This will remove the alerts from the main queue, but they are not deleted, just marked as reviewed. You can also fine-tune how the rule behaves by clicking on the rule name and selecting Tune Detection from the menu. This opens the Tune Detection page. To suppress alerts, click the plus icon, set type to suppress, set track to by source, enter the IP and add a note like known good traffic. Click Create. You can also edit the rule directly by going to the Detection Source section. To view alerts you have previously acknowledged, return to the Alerts tab, click on Options, then select Acknowledged. This will display alerts you have marked as reviewed or false positives. Let's focus on alerts that are more likely to indicate real threats. For example, drill down into the rule, ET malware zbot post request to C2. This reveals 9 alerts involving 3 separate source IPs, making connections to 3 different destination IPs over port 80. This pattern could suggest coordinated or suspicious activity worth further investigation. You can click to expand an individual alert for a closer look. If you scroll down to the Suricata rule section indicated by rule.rule, you will see that this alert is triggered by HTTP traffic flowing from your internal network to an external server. This is a common indicator of command and control activity or data exfiltration. If you scroll up to the Network Data Decoded section, you will see the client is making a post request to a PHP page, using Microsoft Internet Explorer 6.0 as the user agent. This is an outdated browser version, often associated with malicious traffic. The destination host is ishibati.com, which appears suspicious and may need further investigation. Click on Network Data Decoded, then go to Actions, then select PCAP. This will open the full packet capture related to the alert, letting you analyze the actual network traffic involved. Reviewing the PCAP, we can see a clear connection between the internal host and an external web server, with what appears to be encoded data being exchanged. This kind of traffic is unusual and could indicate command and control communication. Go back to the Alerts tab, locate the alert, select it, and then click the triangle icon to escalate it to a new case. This begins formal tracking of your investigation. Go to the Cases tab. You will see a new case has been created, named after the alert you escalated. Click the binoculars icon to open the case and view its details. On the right-hand side, you will find metadata fields. If you are working in a team, use the Assignee drop-down to allocate the case to a specific analyst. Change the status from New to In Progress to reflect that the investigation has started. You can also set the case's severity and priority, apply a traffic light protocol, or permissible action protocol level for information sharing. The Comments tab lets you add notes using Markdown formatting. Each comment is automatically tagged with the author's username and a timestamp. For example, you can add the following note. The Attachments tab lets you upload files or artifacts related to the investigation. For example, you can attach relevant Sysmin logs, Windows event logs, or any other evidence that supports your analysis of the alert. Observables are specific indicators such as IP addresses, hashes, or domains that you identify during an investigation. Some observables, like source and destination IPs, are automatically extracted from alerts and added to the case for easier tracking and correlation. Selecting the crosshair icon next to the first entry will open a hunt centered around the IP address 192.168.3.65, allowing you to dig deeper into related activity. Clicking the lightning bolt next to the first observable will trigger analysis on that item. You can then expand the observable to view the results. This feature requires internal analyzers to be properly configured in your Security Onion setup. The Events tab displays all events that have been escalated and formally linked to the case. The History tab acts as an audit log for the case. It records every action taken, such as items being added, changed, or deleted, along with the username and a timestamp for accountability. Let's revisit the ET malware zbot post request to C2 alerts and narrow our focus to a specific host. Click on the source IP 192.168.3.65 and select Only. This will filter the alerts to show only those involving that IP address, helping us investigate its activity in more detail. Click on the timestamp column to sort the alerts chronologically. From the timeline, it appears there was ZBot download activity, followed by a C2 post request, and then an exe file download over HTTP. This sequence strongly suggests malware infection and command and control behavior. Expand the alert titled etinfo PEXE or DLL Windows file download HTTP to view the full details. Scrolling down to the Network Data Decoded field, we can see clear signs that a Windows executable is being downloaded. This confirms that an executable was likely transferred over HTTP. To view all logs associated with this specific network flow, you can pivot using the community ID, which is a unique hash that Security Onion assigns to each network flow. Click on Network Data Decoded, then choose Correlate. This will open a hunt view showing all logs linked to that same network flow. You will see network metadata from Zeek, along with any Suricata alerts, displayed in the Group Metrics pane. As you scroll down, you will see a list of alerts, alongside the HTTP requests, sent by the client to the external server. Since Zeek file records do not include network connection details, you will need to correlate them with the ZeekCon records to link the file activity to its corresponding network flow. Scroll down to the ZeekCon dataset, click Actions, then select Correlate. This will tie the file metadata to the relevant connection log, giving you the full context of how the file was transferred. After correlating with the connection log, you should now see Zeek file records appear. If you scroll down and expand the Zeek file entry, you will find detailed information about the transferred executable file, including file size, MIME type, and the hash values. You can check if the file is known to be malicious by clicking on any of the hash values and selecting Virus Total. As expected, the Virus Total results confirm that this is indeed a malicious file. To link this file to your investigation, click the triangle icon on the relevant Zeek file record. Then choose the name of your case, under Attach Event to a recently viewed case. If you return to the Cases tab and open the Event section for your case, you will see that the Zeek file record has been successfully added. To add the file hash as an observable, open the event, scroll down to the hash section, and click on the eye icon next to the hash value. This will open the Add Observable pane with the hash values pre-filled. Click Add to save the observable to your case. You can now click the crosshair icon next to the observable to launch a new hunt focused on that hash. This helps you check whether the same file appears anywhere else in your environment, which could indicate further compromise. Threat hunting. Go to the Hunt page in the web interface. From the Query drop-down, select Log Type. This shows all records, grouped by their event modules and datasets. Scrolling down, you will notice a variety of metadata produced by Zeek. To look at Zeek logs, click on Zeek and select Include. This tells Security Onion to show only Zeek events, grouped by both event module and event dataset. Our objective is to hunt for suspicious HTTP traffic. Locate the Zeek HTTP dataset in the Group Metrics pane. Click on it and choose Only. This filters the view to show just HTTP traffic parsed by Zeek. Scrolling down, we can see the list of individual events. To group HTTP logs by destination port, click on the destination port and select Group By. Alternatively, click the stacked paper icon next to the field. Now that we have grouped the HTTP logs by destination port, we can see that while some use the standard port 80, others are going to non-standard ports. To cross-reference this with known alerts, open the Alerts tab in a new browser tab. Drill down into the alert called ET Malware ZBot Post Request to C2. From there, you will see that port 80 is indeed linked to command and control HTTP traffic. Back on the hunt page, click on the destination port 80 and select Include. This filters your results to show only HTTP traffic on port 80, helping narrow your investigation to flows potentially related to ZBot C2 or similar threats. As you scroll through the filtered results, you will notice plenty of GET requests and a few POST requests. Click on the HTTP method where it shows POST. Select Group By. This will group your data by HTTP method, allowing you to isolate and analyze the POST requests more easily, which are often associated with data exfiltration or C2 communication. To focus on the POST requests, click on Post and select Include. We can now see Zeek HTTP requests using POST HTTP method. As you scroll down, you will now spot the same source IPs that were identified in the alert: 192.168.3.25, 192.168.3.35, and 192.168.3.65, which is a strong indication of a match. To investigate further, click on the HTTP request body length column header to sort the events by payload size. Find the first event from 192.168.3.65. Click Actions, then PCAP to open a packet capture view of that session. This gives you a direct look at the traffic, making it easier to identify signs of malware communications like beaconing or data uploads. We are seeing repeated HTTP POST requests being sent to the same URL. Each of these requests contains encoded binary data, likely being sent to a command and control server. If we go back to the hunt page and expand one of the logs, we will see a field called Log ID UID. This is an internal ID used by Zeek to link together multiple logs from the same network flow. There is also Network Community ID, which is a unique hash made up of the source and destination IP addresses, ports, and protocol. To see all related logs for this event, click Network Community ID and choose Actions, then Correlate. This will bring up all events tied to that same flow for deeper investigation. We can focus on the Zeek file records by clicking on Zeek File and selecting Include. As you scroll down, you will see the individual events tied to that network flow. If these events occurred further along the attack chain, they may reveal what the attacker exfiltrated or accessed from your environment. To work out where the initial infection came from, we will need to examine other Zeek file logs linked to the same system. Click on the source IP address and choose Include. Remove the Community ID filters from your query. This allows you to see all network flows related to the selected source IP, not just the ones tied to a single session. There are 11 different file records linked to the source IP, 192.168.3.65, suggesting this host has been involved in multiple file transfers, which may include the original point of infection. As we scroll down, we notice one file is a Windows DOS executable, which is a potential indicator of a malicious payload or the initial infection file. This needs a closer inspection. The next step is to extract the executable from the PCAP file to confirm whether it was the initial point of compromise. After that, you can hunt across your network to check if any other systems have downloaded or executed the same file. The Dashboards feature offers similar functionality, but with a wide range of pre-built visualizations for specific use cases. Go to the Dashboards tab. To carry out a similar threat hunt using dashboards, a good place to begin is the HTTP dashboard, which focuses specifically on HTTP traffic patterns and related events. Select destination port 80 and choose Include to narrow the results. To focus on post requests, scroll to HTTP method, click on Post, and choose Include. This will filter the dashboard to show only HTTP post traffic. Scroll down and sort the tables by HTTP request body length to prioritize entries with larger post payloads. You should now see the same suspicious activity identified earlier in the Hunt interface, confirming consistency across both views. Detection engineering. Go to the Detections page in the web interface. By default, it displays all available rules, grouped by detection language. Suricata rules are used for network-based detection. Yara rules are for file-based detection. Sigma rules are used for log-based detection. Each detection language targets a different layer, network traffic, file analysis, or system logs, giving you a wide coverage across the attack surface. If you only want to view Sigma rules, click on Sigma and choose Include. You will notice that the detection results and the list of enabled rules update to reflect that filter. Most of the Sigma rules included with Security Onion are turned off by default. Each enabled rule runs an Elasticsearch query every few minutes, so enabling all of them could put heavy strain on the grid and affect performance. To inspect a rule more closely, click the binoculars icon next to its name. This opens the tuning interface for that specific rule. The Overview tab shows a summary of the rule, any related references, and the detection logic. On the right-hand side, you will find additional details. This includes its public ID, a unique identifier used internally, the rule type, the rule set it belongs to, its severity, the author, the license, and the dates it was created and last updated. At the top, there is a slider, which is set to disabled. You can click the slider to enable the rule. The Operational Notes tab gives analysts a place to record notes about the rule. The Detection Source tab displays the complete Sigma rule text, including details not shown on the Overview page. The Tuning tab gives you a tailored interface for adjusting each rule type. The History tab gives you a full audit trail of any changes made to the rule since it was first brought into your Security Onion setup. Let's walk through a detection engineering scenario. You have found a gap in your current detections, and you want to be alerted whenever a local user account is created on a Windows machine. To simulate this, we will create a local administrator account on the Windows VM using the following command. Go to the Detections page. Click on the plus icon to create a new rule. In the Add Detection window, choose Sigma from the drop-down menu. Set the license field to None. Replace the pre-filled Sigma template with the following custom rule. The Sigma rule itself does not run directly. It gets converted into an EQL, Elasticsearch query language, and that is what actually runs in the backend. To see this, click Convert to preview the EQL version. To test it live, click Test in Kibana. This will open the query in Kibana Dev Tools and return any matching results. Everything looks fine here, so go ahead and click Create to add the Sigma rule to our list of detections. The rule is not enabled by default, but if you want to activate it, just click the slider to turn it on. Now that the rule is active, anytime a Windows Event ID 4720 is logged, which indicates a new local user account was created, we will receive an alert. To test this, a local admin account named Joe was created. Go to the Alerts page. You should see an alert confirming that the rule successfully triggered based on this activity. You can expand or drill down into the rule to analyze it in more detail. As shown by the event data message, we can see that local administrator accounts named Bob and Joe were created. In this proof of concept, we explored the complete setup process, from installing Security Onion in standalone mode to deploying the Elastic Agent on Windows, followed by a hands-on introduction to Security Onion's core features. In the introduction, we walked through how to navigate the analyst tools, triage alerts, create cases, and perform threat hunting and detection engineering. Security Onion is an incredibly powerful platform for threat hunting, enterprise security monitoring, and log management, providing defenders with the visibility and tools they need to detect and respond to threats effectively. For more details, refer to the Cyber Defense Kit documentation.